into action.
Hello, we are doing our applied project update. My name is Carson Lang.
My name is Elizabeth Bach.
And I'm Carter Gray.
Our group is Bot Sentinel, and we are Group 6. So what is a bot? A bot is an application that does something online. Bots can be fully or semi-automated, and social media is bombarded with bot activity. And so our project is meant to find and identify bots that have bot behavior. So the challenge then becomes, how can we use a machine learning model to accurately predict if a Twitter account is a bot or a human? Current solutions that exist is Botometer. It's an online thing that you can look up yourself, and it uses a machine learning model to give a score to an account based on its activity. A higher score equates to a higher likelihood of being a bot. So we looked at this and we thought, well, we should use their data too. So they released their public data sets, and they are consisted of Twitter that are verified as human, as well as accounts that self-identify as bots. There are 750 bot users and 2,000 real users. And for each user, we took repeats in times for when they update their status on Twitter. And then we took the variance of the most recent 20 status updates in minutes and seconds and determined that as well. We didn't use hours because bots tend to post at the exact same minute and second, while humans may still post within the same hour, but not often the same minute or second. Take it away, Carter.
So for a machine learning solution, we use the Botometer data sets to train our model, and we made a prediction using the Twitter account's activity. For our features, we had one list that looked at the amount of repeated times for the first 20 tweets, and the second feature was the variance of the times of those 20 tweets. For the model, we implemented the KNN, and we used training data as a subset of the total features. For our evaluation, we split the data into training and testing. Then we assess the model's performance based on its F1 score using the binary average on predicting bots correctly. This F score turned out to be 0.9023. For our results, we learned how to interact with Twitter's API. We applied and received a Twitter development account, downloaded and filtered data from Botometer datasets, and created a preliminary model using KNN, then found the F1 score of that model. For our expectations, we want to add more features such as repeating locations, syntax and grammar usage, as well as other forms of engagement. We were satisfied with F1 score and hope to improve it by adding more features. Then we want to apply the model towards a random sample of users, testing accounts using the model. And we want to use KNN predict probability to estimate the likelihood of a bot, like the Botometer machine learning algorithm does. For constraints, we have ethical ones, and it's possible that the model could falsely accuse somebody of being a bot, and we don't want to release this for public use. Also, Twitter restricts the amount of data a developer can request, making large pools of data limited. There are also cyborgs, which are accounts that are half human, half bot, or some iteration of that, and we don't exactly know what to do with these.
When problems have come up so far in our project, we change our approach. For example, we wanted to have a model that answered the question as a yes or no to whether an account was a bot, but we decided this won't work as well because a probability is a better approach, because it's impossible to know if a user is truly a bot unless we manually check it. We expected the user to be able to enter any username unless it's a private account to determine the probability it's a bot. It was difficult to find significant data, but the features we ended up using for the model were repeating and variability of times. We used the F1 score to see how well it did, but there's still room for improvement. And it was difficult to understand how k-nearest neighbors worked with our data, but we were able to graph the clusters of our data before applying. This helped us to visualize our data to be able to test more features and models later. We didn't have a super detailed timeline initially, but we met weekly and always assigned tasks to be completed before we met next. It took longer than expected to finalize our data until we found the Botometer data, because it's difficult, like I said before, to create manual data unless we checked every single account. We also all learned how to use the Twitter API and Tweepy and search for bot data. and we all helped to create the preliminary model, determine the feature selections and extraction methods. By April 9th, we want to finish researching models and features that would be effective for predicting a bot. By April 16th, we want to create evaluation visuals. And by April 23rd, we want to begin producing the final presentation.